All right, so in this video, we're going to look at how to deal with definite integrals with u-substitution. All right, so you're going to first identify what your u-sub will be. So in this case, u would be the x cubed minus 3x squared. And you take your derivative as usual. So your differential du is going to be the derivative of u, which is 3x squared minus 6x, and then all of it times dx. And we can then divide both sides by this, and we have that du is going to be, divided by, and I'm going to factor a 3 there because that's going to give us our term here. So factor, that's going to give you dx, and you go ahead and take back your substitution. So far so good. So far everything is the same we've been doing before. I'm not going to talk about the endpoints just for a moment. And here I can write this x squared minus 2x. Now this right here is my u, so I'm just going to write it as u to the fourth. And now instead of dx, I'm going to write du all over 3 x squared minus 2x, and as you can see, that's going to cancel. However, I still have to address my endpoints, and what's going to happen here is I cannot write 0 to 1 because those are the endpoints where the interval over which I'm integrating with respect to the x variable. However, I'm changing my variable to u, and now I'm integrating with respect to u, not with respect to x. So what I need to do is find what those endpoints get transformed to. So when x is equal to 0, yx equal to 0, because I have a 0 here, and that corresponds to my integration, variable integration x. So when I plug that into my function for u is going to be 0 cubed minus 3 times 0 is still going to be 0. So this endpoint becomes 0. Now at x equals to 1, u is going to become, well, 1 plugged into this expression is going to be 1 cubed, which is 1, minus 3 times 1, which is going to be 1 minus 3. That's going to give me negative 2. So it doesn't matter now that my integral is going from a larger number to a smaller number. That's still okay because the sign of the integral will correspond to the sign of this integral. So it's okay. Don't reorganize them to go from smaller to large to smaller to a larger one. Keep it in the order where you found them. So now we can continue with our integral like nothing happened. And we can apply our fundamental theorem of calculus. We're going to cancel this out, and I'm going to have a 1/3 of u cubed. I'm going to have to leave that u cubed, u to the fourth. Sorry, I'm going to have to leave that 3 inside. I put it too close to the equal sign, my integral, so just leave it there. That's okay. All right, so that canceled out, and now I go ahead and integrate as usual. So I'll just do u to the fifth over 3 times 5. So just adding 5 to the exponent, so 1, and then putting it there. And now I'm going to evaluate it between 0 and 2 by the fundamental theorem of calculus. So when negative 2 rather, that would be important not to mess that up. All right, so whenever I plug my negative 2, I get negative 2 to the power of 5. That's going to be negative 32. The 3 times 5 gives me 15. Minus, and I evaluate it at 0 next time. So this is going to be 0 over 15, which is still 0. So my integral becomes, and as I said, the sign of the integral will be the right one if you keep the right order, so don't change it. So my definite integral becomes negative 32/15. All right, so that is the if you want to call it the more proper way to do it. Some people do not like changing the endpoints, and what they will do, they'll compute first the antiderivative without any endpoint, so not the definite but the indefinite integral. Once they computed the indefinite integral, then they'll go ahead and use the first fundamental theorem of calculus, or second rather, to plug in the endpoints and get the result. So meaning that they would compute the antiderivative, take back the substitution, so bring it back to x, and then plug the original endpoints. Now, I will advise against doing that in this class because there will be several times when we'll be doing multiple substitutions one after the other. So then whenever you have to take back all your substitutions, it may get confusing as to what variable has which endpoints. But if with every substitution you change your endpoints, like here, then when you get to the very end, you don't have to take back substitutions, you just evaluate. So I really recommend you do it in this order. You don't do just the antiderivative and then plug your endpoints, because then that can become confusing once you're doing more than one substitution at a time. All right, this is a short video, so I just wanted to show you how to do the definite integrals properly. All right, that's that, guys, for this one.